Hello and welcome to a Python 3 Basics tutorial series. In this series you will learn the building blocks to the Python programming language. A bit about the language: Python was created by Guido van Rossum in the late 80s, and then from there Python slowly began to gain recognition and popularity. Python 2.0, which is really where Python gained a lot of traction, came about in 2000, and then finally Python 3.0, which is the version of Python we're covering here, came out in late 2008. Python is what is known as a high-level programming language, which means it has a decent distance away from raw kind of machine code. This high-level nature makes Python a fantastic choice as a first programming language because the syntax is very simple just to understand compared to many other languages, and the wide range of tasks that Python can cover is staggering. So that's kind of why it makes such a good language. For the most part, you should be able to look at some Python code and understand what is happening, even if possibly you're not a programmer. There might be some confusing things there, but for the most part it should kind of make sense even visually to the non-programmer. So with Python you can do all sorts of things, data analysis, visualization, to robotics, to web design, and a whole lot more. So Python is a scripting language, and it's interpreted at runtime. So a scripting language just means that the program is read line by line. This means that any errors, besides any syntax errors, these errors are going to not be discovered until the program goes line by line through the program and will basically run all of the lines until the error, and then it will finally arrive to the error and throw the error, as opposed to compiled languages where they're compiled at run, and if there's an error somewhere in the program, it's going to show right at the compiling of it. So with that, let's go ahead and get started. Now, how do we actually get Python? So first we're going to need to head over to python.org, which is what we're staring at right now. And if you come here, it may look a little different depending on when you actually show up to the series. If you're watching the series right now, the current version for me is Python 3.4, but you might be watching this and maybe 3.8 is out, for example. As long as it's Python 3 something, everything should be similar, and the creator of Python and the developers of Python at the moment are saying that even later versions should be completely workable between the versions, as opposed to there's a lot of major differences between Python, say 2.7 and Python 3.4. So once you're on python.org, let's click on downloads. You could just go straight to one of these downloads. It's obviously sensing that I'm on a Windows machine. And if you want to download 32-bit Python, then feel free, but if you happen to have a 64-bit operating system, I would kind of suggest that you not download this one. You should go with the 64-bit version of Python. And the reason for this is 32-bit operating systems and then any 32-bit programs are going to be limited to 2 gigabytes of RAM per instance. So anytime you're trying to do something that's going to require more than 2 gigs of RAM, your program is going to just stop and come to a grinding halt. And so that's no good. So if you have a 64-bit operating system, you should definitely have 64-bit Python. So for me, I'm Windows, so I'm going to go ahead and click on Windows. And we can see all of these releases. We're actually interested in the most recent 3.4.1 here. They're also still releasing new versions of Python 2.7 as well, just simply because there are still people that program in Python 2, because there is a pretty staggering difference between the two of them. So a lot of Python 2 code is not compatible with Python 3 code or a Python 3 interpreter. So for this reason, a lot of businesses are being run off of Python 2.7. They simply can't make the switch to 3.4 without a lot of work. So that's why we have that happening. So anyways, let's click on 3.4.1 or whatever the latest one is for you. And you can come down here and we'll go to download. Please proceed to the download page. We'll click on that. And for me, again, I'm on a Windows 64-bit machine. Now you can download whichever version you want. You can also download the source. If you're on Mac OS, you can download here. Although if you are on Mac or any Apple computer, for the most part, you should have no problem. You actually should have Python already installed. It would behoove you to check if you're on a Mac. Anyway, coming down here, I want the Windows x86-64 MSI installer. for the 64-bit Python, so we'll go ahead and install that. And whenever that's installed, go ahead and run. And next, next. I already have it because I use Python 3. Next, 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 next. This should pop up here. We get some like pip and all that setup tools. It looks like it installed. Finish, and now you're all done. So now what you should be able to do is, for example, we can go to computer and you can come over into your C drive and you should have a Python 34 directory. And within there is basically everything. Now, to program in Python, you're going to do the following things. So if it really depends on preference. Now, some people prefer to type in a interactive or live IDE, and IDE stands for Integrated Development Environment. Python's IDE is actually called idle, like IDLE, and the L is literally just the development, so nothing special about it. It's still an IDE. And so there are other IDEs as well. Eclipse is a popular IDE that people use, especially for like Java, and there's a Python extension for it. Also, Wing IDE is a paid IDE that is very popular among Python programmers. You're also going to see people using IPython Notebook, which is a live interpreter. I prefer to just use the basic IDE, so that's what we're going to be showing in this series, and I'm going to show you now how to get to that. So if you've installed Python 3, what you're going to want to do is go to your start bar and then you click on all programs, and then you should have Python 34, and if you come down you should see idle and then in parentheses Python GUI. Click on that and up should pop something that looks like this. Now this is basically it is a Python shell, and it's a live interpreter, so you can type stuff into here and it's going to basically input this into the Python and be interpreted as Python code. So if we just entered this isn't very valid code. So if we hit enter, we actually get an error and it says that's not defined because it was expecting it to be a variable. But now we can actually, let's type our very first program just to kind of show off this interpreter here. And for now we're just going to have it output something to console. So we're going to use this print statement, and we'll cover that a little bit more in the next chapter here. But for now, print and then put two round brackets here and then two quotes, and let's just do a simple hello world. Now when you've done that, we can hit enter and we see that the output is hello world. So this is just a simple print statement, but it basically is showing the live nature here. So after we finish this line, it basically threw out, this was your input line, this is your output line. Now, I don't really like programming it in this sort of fashion where everything is live and each line that you write has, is input and then you get the output. I don't really like that. I like to just program more of a notepad type fashion. So to do that, we're going to go File, New File, and now you have this blank sort of document, right? So we can also type the same thing that we just typed here, right? So we can go print and hello world again. And this time, to run it, first we're going to have to save this file somewhere. So let's go File, Save As, and we could put it there in Python 3.4. It really doesn't matter where you put it. You can put it wherever you'd like. For me, I'm just going to put it there for now. And let's just say example py, and this is going to be example py, and we're saving it as a .py. So let's just go ahead and hit save, and we're all done. And now when we want to run this program finally, every time you add new bits of code to this program, you'll have to save it before you run it. But you can either go run module, or you can just use the F5 key and that will also run it. So if I hit F5 right now, it's currently unsaved, so it's going to come up with this little box here. It's going to say source must be saved, OK to save. I'm going to hit OK. And then we see that there the program has run again. And that's really it. So that's going to conclude this chapter of the introduction to what Python is. Just a brief introduction to this print function, but we're going to cover that more in the next chapter. How to open up the IDE, what's the interactive IDE, and what's just this kind of notepad IDE here, and all of that. So anyways, stay tuned to the next chapter. Hello everybody, and welcome to the second part of our Python 3 Basics tutorial series. In this series, what we're going to be doing is talking a little bit more about the print function as well as strings. Since they go hand in hand, it just makes sense to cover them together. So let's go ahead and get started. So in the previous chapter, we talked about just a simple print, and we did print hello world like that. Now, what we're going to be talking about is some of the rules of the print function. So the print function is going to act like any other Python function, which we'll have to cover in a little bit, but a function basically has its name, and then you put parameters of a function within these round brackets. So the print function, all it's going to do is just output whatever text we put in, or really whatever we put in as the parameter. Now this could be text, this could be a variable, this could be all sorts of things, but for now we're just doing simple strings, which strings are just text. So, as far as strings are concerned, what are some of the rules of strings? Well, first of all, we have to have obviously some sort of quotes around our strings. So we've used single quotes, but we can also have double quotes. So we can do something like this, double quotes. And that will also work. Let's go ahead and save and run that just to see our output. So there you go, you have hello world, double quotes. So we see they both kind of act similarly. We already know that we can have single quotes. The other thing that we can do is something like this. So we can say print, and then we can do what's known as concatenation. So we can do something like this, concatenate plus, and then tion, so for concatenation. And what concatenation is going to do is going to add these two things together. Now there's two ways that you can put things together. This is the first with this plus sign. So we can save and run that again, and we see that concatenation actually put these two things together. So it looks like it's all one, but obviously in the program it was not. But we can also do something like this. So we can do hello, and then another way you can join things is with a comma there. And if we save and run that, we'll notice a slight difference where hello there actually came with a bit of a space. And that space is because we used a comma. Now, why might the developers of Python decide that there's two ways to put things together, plus and a comma, and the comma just is a space? Like, why not just add the space ourselves if we wanted it? Well, the reason for this is actually not for strings at all. The purpose is for if we want to combine strings and something like integers. So the following would be an example of why. So we would say something like I am and comma 5, let's say. Meaningless, but let's go ahead and run it. And we see the output here is I am 5. But what if we, instead of this comma, tried to use a plus? Now we're also going to see the scripting language, line by line characteristic of Python, because everything up to this point here is going to work, but this will fail. So anyways, let's go ahead and run that. I am plus 5, and we see that we can't convert an int object to a string implicitly. Basically what it's saying is you can't add integers to strings. That's pretty much it. And actually what it actually tries to do here is add a string to a string, because it started with a string, and it found it could not do that. But what if we did something like this? 5 plus I am, like that, we would get a different one, a different error, right? Because initially it was trying to call a string as an int, or I mean an int as a string, and this time it said that we can't add a string to an int using, the addition. Now I know that might feel like there's a lot of rules already, but we actually have a few more that we have to cover. The next thing that we need to know is how do we add something like the following. Let's say we wanted to say I'm 5, right? Since we're apparently fans of I5, we'll say like this, I'm 5. Well, obviously that's not going to work out, because with this, what we've attempted to use as an apostrophe, we can't, because it's thinking that it is some sort of closing quote, and then we've got an open quote here. Obviously this isn't going to work. It's going to say invalid syntax because we've got this random floating unclosed stuff here. and then a random m that makes no sense. So how do we get around this sort of scenario? Well, there's actually 3 ways that we can handle this. The first is with an escape character, which is the backslash, which is the key that's right above your enter key. So for example, the backslash is an escaped character, and what it's going to do for you is any character that you add this escaped character before, it's going to escape from the characteristic of that character. So in this sense, this is actually, it's an it has a characteristic of beginning and ending strings, where if we put this backslash here, this escaped character here, it takes away that characteristic and just treats it like an ASCII character. So we can run this. Oops, we still left this one. Let's get rid of that. And in fact, let's clear away all of these just so we're back just simplistic here. Now we see I'm 5, and it was able to print that. So that's the first way that we can handle this. The second way that we can handle this is instead of having single quotes here on the outside, we can make these double quotes like this. And now these double quotes initiate this whole sort of statement, right? And then the single quote is treated like a single quote and not the beginning or end of a string. So we can run that, and it says I'm 5. Now the third way is a little less conventional, and there's really no great reason for it unless you wanted to quote somebody. So for example, let's say you really wanted to you didn't want to use escaped characters, and instead of I'm 5, you wanted to say he said, and instead of single quotes, instead of like hi, like that, using single quotes, you wanted to use double quotes. Now we see that we're having trouble. Well, we can actually get around this as well using a very similar practice, and that was as the second option, and we can just use single quotes to encase the double quotes, and we can see he said hi in double quotes. So those are 3 ways that we can get around the whole issue of quotes and all of that. And another thing to keep in mind with the escaped character, now that we've taught the escaped character, we might not cover it too much more in these basics, but the escaped character is often the character used in file paths. And so later on when we specify a certain path to a file, generally Windows displays file paths like this, C:\\, let's say users, blah, 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 blah. You have to be very careful because it's going to use that backslash, and you can see that this backslash will escape characters, and sometimes it causes a lot of trouble. So you can either fix that with double backslashes, or you can just change the backslashes to /. So that's going to conclude this chapter, and in the next chapter we're going to be talking about numbers, ints, and floats, so stay tuned for that. Hello and welcome to Chapter 3 of Python 3.4 Basics. In this video we're going to be talking about simple math with numbers. So ints and floats are the data type that covers numbers, and then also the other data type that's very popular, strings, which we've already covered. So let's talk about numbers, ints, and floats. So with Python 3, you're able to treat it very much like a calculator. So we're able to do the following. We could say 1 plus 3, for example, and we can go ahead and save and run this. And 1 plus 3, well, it's not going to print it out for us, but we can do this. 1 plus 3, and it outputs 4. So instead what we could do is we could say print 1 plus 3, like that. And we get 4. Now we're able to do basically all the operations. So to cover them, we could do plus 1 minus 3, 1 times 3, and 1 divided by 3. So for multiplication we use an asterisk, and for division a /. So we can go ahead and save and run this, and we get all of these numbers. Now these are all integers, right? 1, 3, 1, 3, 1, 3, 3. These are all integers. Now a float is it's basically a decimal number. So a float would be something like 1.5 divided by 3.6. These are floats. So we can save and run that, and those are your floats. So this is just simple mathematics. With Python 2, you couldn't do very smart division. So 1 divided by 3 would actually result in kind of a silly answer. It wouldn't actually result in 0.333. And you would have had to do 1 divided by 3.0 or something silly like that. But with Python 3, and greater, your division acts very normally, so not too much to cover there, just the notification that this is how you do mathematics. The next thing, too, that we can cover is something like exponents, for example. So say we want to do 4 to the power of 2. So we were hoping for an answer of 4 times 4, which is 16. So actually, let's print that out. So we'll do print 4 to the power of 2, save and run that, and sure enough, we do get 16. So that's just some simple, how to do an exponent. So that's just simple mathematics with integers and floats, what they mean and all of that, how to use them, and the symbols, maybe the multiplication, division you wouldn't have known. But anyways, very simple topic. So that's going to conclude this video. In the next chapter, what we're going to be covering is variables. So stay tuned for that, and thanks for watching.